Come on, guys. You can be as interactive as possible with Harsh. Harsh is very open and very cool. He can suggest you quite a lot of things.
Yeah, and it's fine if you, and if you say wrong things, that's fine. Like that's totally okay.
I mean, I can talk a bit about MongoDB, but again, it will have a bit of jargons and all that. So
That's
explain.
fine.
Yeah.
So that's okay. But like I'm trying to make it as simpler as it is, like without using a lot of technical terms, because like that's what I
Yeah.
consider happens everywhere,
Yeah.
right? So do not make it intimidating for people. Fine. Anyway, so like anyone who is here from the second year or like third year, just say a yes with your mic open. Like the reactions are not as good apparently. Okay. No one is here from the second year of batch, because like I expect people to like have done some kind of database in them. Um, yeah, fine then.
Yeah, there are people, but they're not showing up ideally on the call. They're not speaking up.
Yeah, fine, folks. Okay, let's make cool. Let's just go through the slides then, I guess. Um, Fine, folks. So, yeah, what we'll do is we'll understand blockchain in simpler terms. We'll understand why it is such a hype right now. Like, whenever, like, when this cohort was announced as well, like, why did you guys sign it up, right? It might be because of a FOMO, fear of missing out, that everyone else is talking about it, and I should also know something about it, right? So that is some kind of thing, like when it's a peer pressure kind of thing as well, that all of my friends are talking about bitcoins and cryptos and whatsoever, and I don't know thing about it. So that's also fine. uh, it is a cool new tech, and we'll talk about and how it is getting integrated in our lives as of now, and simple information which will help you understand the basics of it. And if you like it, you are very much welcome to work and create projects into it. So yeah, that's pretty much good part. Like as usual, like this is a two-way street, so yeah, it would be very much helpful for me if you guys talk. So yeah, uh, yeah, all these are a lot of concepts which are in the next few slides, which took me a couple of months to understand. So I'm pretty sure it will be. I'll try to make it as simple, but if there are any doubts, just please speak up. Okay, and yeah. So let's get started. So that's an introduction slide of me. Uh, I am a full stack blockchain developer. I have been into the blockchain development space since almost 2 years now. I'm currently developer relations engineer at Web3 Auth, which is which is a wallet company based in Singapore. And other than that, I have some kind of things done in my past. So basically all of them. And if you have doubts, and if you are after these, like I'll be taking sessions for the next few days, and if you are having any kind of doubts, you can ping me on Twitter as well. That's my Twitter handle, 0xhersh1001. That easy to remember. So yeah, basically if you have doubts after the session, you can ping me there, or if there are any general type of queries, or if you just want to tell anything, basically you can just reach out to me. That's fine. Yeah, so that's about it. So let's talk about what cryptography is, and what does it provide, because like it's a new tech. Whenever it's a new tech, we only see now what kind of use case it has, right? When basically machine learning came in, we were using it for voice recognition, then we built stuff like Alexa, and now we have Google Home, through which you can control your house applications, right? So that was a use case of machine learning, that because it can understand our language, because it can understand what we speak, we can use it to make our lives easier, right? So at the core, what does crypto provide us? Crypto provides us decentralization and power to program money. Okay, these are the core simple values which are provided by crypto. Like all the other things which are there, obviously they do matter, but at the end we just care about decentralization and power to program money. So what do you mean by decentralization? So currently the world is run by a bunch of like just like few of the companies, right? Few of the companies, you guys know which companies, they run the entire world. And that is kind of a centralized, because if these companies go down, or if these companies try to leverage that, we are on their mercy. Basically, we cannot do anything. And that's why it is centralized. So what would be the decentralized version of it? Decentralization would be that we do not have any kind of central authority, and we handle it using a peer-to-peer system, right? So a cool example of peer-to-peer system would be, if you guys are famous, if you guys have played around with BitTorrent. BitTorrent used to be a software where people can download games and movies and all of it, and different ways. Like if there is a new movie coming in, you can download it using BitTorrent. You used to find peers, and then you used to download stuff. So I personally have used those for like playing games and whatsoever in my childhood, and that was a decentralized manner. Because like what I used to happen behind the scenes was, there was this one guy who used to get all those game copies, and that guy used to send it to a network of people. And if you are one of those person who wants that particular game, you can download it in your system. So all of this is happening in a peer-to-peer system. Like all of us as are peers in the network. One guy has the information, and that guy is sending the information to the entire network, and whoever requires that um, can easily get it. So that is a decentralized manner, because we do not have a central server like uh, not a central server like a Google Drive or something like that, because it all happened in a decentralized way. So yeah, like even right now, if we have information on some website, those websites can still go down if the government of that country decides to do so, or if uh, uh, if any kind of thing happens. So basically, that is a centralized thing, and a decentralized thing is where a peer-to-peer network takes place. Yeah. Any doubts till then? Any doubts till now? Just turn up your mic and we can talk. If there are no doubts, just turn up your mic and say no doubts till now. All cool.
Yeah, no doubts till now.
Thank you.
No
Thank you.
doubts.
Yeah. Cool. Anyone? No doubts till now, right? Yeah, fine. So that's decentralization and the power to program money. So currently, money as we know it is in the last few years, it has transferred from paper money to digitalized money now that we have UPI. But still, we do not have the power to program that money. There are obviously tools which do that. There are financial companies which do that, fintech companies which do that, but those are also kind of, they need to go through a lot of documentations, and there is no freedom for you. Like if you want to have the power to program money, you kind of need their SDKs and APIs and whatsoever, and then you can do that. But there is no freedom in that, and that is what crypto provides us with. So the power to program money, and that too independently. So these are the core values which crypto provides us. So, and how is this useful? Why is this useful? Let's talk about it in the next slides. Cool. So yeah, like these are some of the things which are happening as we speak. So this is how the crypto coins, which you know of them, are getting integrated in our daily lives. So Stripe, which is a international payment uh, company, like if you want to send money from here to there, majority of companies send these, like Stripe does payments, like it does payments internationally, and now it has started to do payments using crypto. So that's a big thing, because Stripe is a big company, and if that company allows global payouts with crypto, that's a huge thing. That this particular new asset which we have, which we call crypto, is now being used as currencies. So Bitcoin came up with these credit cards, which through which you can use your Bitcoin in, like however you use a Visa card, like it's a Wi-Fi tap card. You can just tap it out, pay for your bills and whatsoever. So that's something new as well. And Solana opened up stores at multiple places like New York City, where you can buy uh, things like shoes and whatsoever, like merchandise, and you can pay using cryptocurrencies. So these are like basically getting integrated in our daily lives. So we can talk about this. And then Starbucks, which is a pretty small company, has integrated NFTs into it for unique experiences. A few days back, Nike announced that they are doing this. And the very, very cool thing about it is that majority of these big players, big brands like Starbucks or Disney or Coca Cola are using Indian origin blockchain, which is Polygon. So Polygon is an blockchain which was created by Indian engineers, and then now it is a global company, obviously. And all these major players which have big audiences, uh, like Nike, Coca Cola, and Starbucks, are integrating it with that. So that's kind of a proud moment as well, that we have created software which basically is helping the world. So yeah, that's a plus point. Yeah. So these were all the news basically regarding what is happening currently in the world, and how this particular uh, change is getting how this particular change is getting what getting particularly initialized in our daily lives, I would say. How is this getting integrated basically? Yeah. So these are current news. There are obviously a lot of other headlines as well, and yeah, you can go through those. And well, now the a very basic question comes up, which I asked in the beginning of this particular class, which was what is blockchain, and the answer to it is three long words. We'll break down each of these words. Decentralized immutable ledger. Okay, so yeah. Any doubts till now? Or like if there are no doubts, please just say no doubts.
No doubts.
No doubts. Yeah. Why is there like, I guess, why like it would really help a lot to me if everyone can just talk, because it will not feel like I'm talking to a wall, to be honest. So yeah, that would help me a lot, to be honest. Folks.
Question.
Yeah.
Yeah. So, what's the difference between crypto and NFTs?
Yeah. Very cool question. Um I would say we are not like I would say that's a second class question. Like this is the first class right now. If we answer that question in the second one, that is also doable. But so cryptocurrencies are basically blocks. Can I answer this question after I show some of my slides, because that will help a lot behind because
Yeah,
of
yeah,
the
sure.
context.
Yeah,
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 cool.
cool.
Anyone else? Or there are no doubts, or everyone is a wall basically? Folks, fine. Uh, Okay, let's talk about this. Let's talk about what is the blockchain. So decentralized, I just explained decentralized. What it means is there is no central authority controlling anything, and yeah, we are having a peer-to-peer system. And immutable means something which cannot be changed. Okay, and something which cannot be changed once written. So basically, yeah. So it is as simple as it can be. And a ledger, so a ledger is basically a book in which we add data. So consider, um, can anyone explain to me how banks work today? Can anyone like explain how normal banks, like all of you might have a bank account, so can anyone explain what banks do? um, they can just like open up the mic and talk. Kind of waiting on you guys, people.
Like if we do a transaction from one bank to another bank, they just don't immediately transfer the funds. They keep a record of all the
money transfers and do it at the end of the month or end of 20 days or something like that.
Exactly. So whenever you are using a UPI application, like a Paytm or a Phone Pay, so if you are sending money to someone else, does the money actually go from your account to their account? Like, is it physically transferred?
No.
Right. It's a no, right? It is not physically transferred, it's just a transaction. And who stores this transaction?
The host bank stores the transaction.
The host bank stores the transaction. So the place where these transactions are stored is called a ledger. So a ledger is just a book which stores all the transactions which are done by hand. Thank you for the answer. And yeah, so what now these three words mean combinedly are decentralized, which is not controlled by any central authority, and it is immutable, which cannot be changed, and a ledger, a book which stores all the transactions. Yeah. So currently, the financial system of us is controlled by banks, and yeah, that's kind of like a centralized win, because like the bank has the authority to change the transactions and whatsoever. They can do whatever they like, right? But so that kind of has, to be honest, made problems for us, and it has showcased like how fragile our financial system is. That's why the blockchain was invented. So yeah, like this is we'll have a blockchain, like I have a particular app with through which we can play around what a blockchain would be. So yeah, like now basically the question is, why do we need it? So the Bitcoin birth was around 2009, when the entire financial crisis happened. So what happens is, like my earlier question is how banks work, right? So if you're a person who has a lot of money and you want to deposit that money to a bank, right? So what happens is you deposit the money to the bank, and the bank will take this money and loan it to someone else. Yeah, it will loan it to someone else, and they'll charge interest for from them. And what will happen is, they'll get more interest, and then when you require the money, obviously they have a lot of money because a lot of people deposit funds into the bank. And bank what does is, like, they loan out using this money. So they earn interest from others, and then they return you the money. They also give you some kind of interest, just for you, because you stored your money there, right? Everyone understands this? Yeah.
Yes.
Yes.
Yeah.
Yeah.
Yes.
Yeah. So what happened in 2008 was, like, banks ran out of money. Banks went bankrupt because, like, banks gave out a lot of loans, and a lot of other crises also happened. Even the stock markets were crashed. The a big when big things like these happen, then we understand how fragile our financial system was. So what happened was, bank froze all the withdrawals of money, so you cannot withdraw from your own account. And even though it's your money stored in the bank account, you cannot withdraw, because like bank doesn't even have the money to withdraw now. This is the time when ATMs were a thing, when UPI or digitalization was not there. This is 2008, this is 14 years ago. Yeah. So this basically tells us that how banks have ruined, can ruin our thing. Like, a lot of people even died because they were not even able to have money to buy food and things like that. And this happened globally, which is a very big thing. India particularly was not that much affected, but a lot developed countries like USA were very much affected. So this kind of tells that we cannot trust banks to keep our money safe, and that's why we need a decentralized immutable ledger. Yeah. So that kind of gives you a why, that why do we need a blockchain? Because centralized forces have failed us, failed our trust, that we trust them. Whenever you are making a bank account, you trust that bank that they'll keep the money safe, and the bank will keep the trust because they want their reputation to be saved, right? If a bank has a good reputation, more people will make accounts with them, and the bank will get profits basically. Yeah. So that trust has kind of lead us to into problems, and that's what this particular thing gave birth to Bitcoin. So Bitcoin was the first cryptocurrency which actually was working. So the work behind these cryptocurrencies, and how these things are maintained, like how do you even maintain a decentralized immutable ledger? Right now the question arises, like if a bank is maintaining a immutable ledger, if a bank is maintaining a book of transactions, that is fine. But if now we want to remove the bank. Yeah, now we do not want the bank to do this. We want all of us, like a peer to peer system, to do this. Like we all of us in this room can create a book, and we'll just do a transactions, and we'll just keep on adding those transactions, right? But now we need to do it in a safe way as well. Like anyone can add transactions, but what if someone does wrong transactions, or someone is malicious, or someone is just a villain, and they want to just like play fool around with these people, right? So you cannot trust anyone. And we need to make a trustless system, that in such a way that the entire blockchain works perfectly, the entire ledger is working perfectly, and no attacks can be done, the data cannot be changed, and yeah, well, we need to have some kind of system in that. Yeah. So this is what Bitcoin proposed. So yeah, let's go to the next slide. This is too much talking, so let's try some cryptography. Let's do a demo. This is a very cool website through which you can understand and play around with your own blockchain demo, and we will understand this. Okay, so I'll have a few questions. How many of you guys understand what a hash function is? And if you know what a hash function is, can you define it? Can you just like turn on your mics? If anyone knows what a hash function is, this is like hash, HASH. If you guys have been studying DSA or anything, it has a hash table. If that's also something. So can anyone explain me if they know hash function? If you guys don't know, just like turn up your mics and just say we don't know. It's fine. That's also okay. I'll explain it.
We don't know.
Yeah,
Yeah, we don't know.
fine. So how many of you guys use GitHub? You guys use GitHub or Git or whatsoever?
Not very frequently,
Harsh,
but sometimes.
You guys use
most
Git?
of the guys like Harsh, most of the guys created their GitHub like yesterday,
Okay,
and
fine.
their MetaMask also.
That's totally fine. Okay. So okay. So if you are someone who knows Git, Git uses hash functions. So yeah, just a cool random fact that it uses hash functions. Okay. So how many of you guys understand mathematical functions? Mathematical functions are basically f of x. You just put in some input and you get some kind of output. Easy, easy to understand. Yeah.
Yes.
Yeah. Cool. So now consider what a function is, a mathematical function. It takes in some input and gives some kind of output. We don't know what kind of output or whatsoever. We really don't care about that as well. And so what a hash function does is you put in some kind of data into it. The data can be anything. The data can be sentences. The data can be binary code or whatsoever. And a hash comes out of it. What is a hash? Hash is a fixed string which contains alphabets and numbers. Okay. So let's just try. So hello everyone. So what happens is when this particular data, hello everyone, is put into a hash function, this kind of output comes out. So this is a string of a fixed length, and it is considering of numbers and alphabets. Can you read this? Yeah.
Yes.
So
Yeah.
yeah, it would be very much cool if this is like a conversation rather than just like one-sided talking. So like all of us, if I'll ask, like even if you are having, if like 10 people, like all the of us can open mics, that would be very much cool, because like that would seem like a conversation and it would be interesting for you too as well. Yeah. So just like keep a check on this particular data. So whenever I'm changing this data even by a bit, if I remove the exclamation, this hash which is showcased below will change. So it is changing with every change I make. Even if I'm adding a space, it would change. So hash function basically takes in data and puts out gibberish. But one cool thing about it is that every data will have a different hash. You can so what we expect is that whenever we are putting in data, we expect a different hash if the data is are different. We want that.
Excuse me.
Yeah,
So is hash like address of a variable in C?
it's not an interest. Like what it does is it takes in some kind of data. Data can be anything, and it will always give out a string of a particular length. It can be gibberish, like right now this thing won't make sense to you, but this hey, you can read a hey, right? But now what we do is we are basically encrypting the information. Encrypting information is we just want to hide it in such a way that no one else is able to guess it, right? So
Yeah.
we want it to be one sided, that if we put in some data, it should turn out, it should have some kind of output. And obviously if I give you this output, you will not be able to guess what was the data. Yeah, so that's
I
what a
see.
hash function does. It's
Cool.
basically
Thank you.
encrypting. Yeah, that's fine. So yeah, one cool thing, I'll repeat it again, that every time we change the data, the hash changes tremendously. Like it's not just like a single change, the entire hash changes basically. So this is known as the avalanche effect. So avalanche basically is a natural disaster that a very small tiny snowball comes rolling and then entire a huge chunk of snow falls away, right? So that this is avalanche effect, that even if you add a very small thing into the data, the entire hash will change up. Yeah, so this is a very cool feature. And if hash function doesn't have, so like there are a lot of hash functions. We are currently using sha256, which is just one of the very cool hash functions. Like this is the coolest kid on the block, basically coolest kid on the hash blocks basically. Yeah, so what we are trying to do is just like putting data and trying to get hashes out of it. Okay, so this is I used a lot of time to explain this because this is the most fundamental thing you can learn about a blockchain. So now let's talk about a block. Okay, so this is a block. So what happens in a block is there are few fields and there's some data. By the way, there are any kind of doubts till now?
No, no, that's
That's
I have a doubt.
sure. Go ahead.
So for a given hash output, can we decode it to get the data?
No, we want it to be one-sided encryption. Like if you have the data, you can get the hash, but you if you have the hash, you cannot get the data. We want it to be that way.
Okay, thank you.
Yeah, so it's just a one-sided encryption. So now let's talk about a block. uh, if there are any more doubts, you can just like interrupt me in between, that's also fine. So what happens in a block is, so when we are talking about a blockchain, if you guys understand simple chain, like we are just connecting blocks. There is a number one block which will be connected to the number two block and number three, and it will form a chain. So each of these blocks will have some kind of data. And what we do is, let's just put in some data. So let's put a again. And what we want now is we want the starting four characters of the hash to be 0. Okay, so the block number, the nonce and the data are put in a hash function. And what we want is the hash, the first four digits of the hash to be 0. So we cannot change the data, we cannot change the block number. What will we change, folks? Anyone? Like what we are doing is we are basically sending these three inputs, the block, nonce, and data, into the hash function which I answered earlier, and we are getting this hash, right? So what will happen is, when so this block turned out to be red because the first four characters of this hash are not zeros, these are something else. So what we do is, when it comes to mine, So what we are doing is we'll change the nonce. Nonce is a number which is used once. Number which is used once. It is short formed as nonce. Okay. So what we'll do is we'll just keep on changing this number starting from 1 to whatever and to infinity, and we'll just put in these numbers into the hash. So like what we'll do is just like put in 1, so the block number will be 1, the nonce will be 1, and the data will be hey. So when we put these three fields into the hash function, this is the hash we get. Then what we'll do is we'll just do 2, then with 3 and 4. This will be a loop until we'll stop the loop when the first 4 digits become a 0. So if I click mine, so it will do it for me. It will run the loop, and it says that when we put in 29,636, we get the first 4 digits to be 0 in this particular data. And if we change the data, the hash will change. So we'll need to mine it again because the data is
So why
changed.
does it have to be zero every time, like the first four digits?
It's kind of like a algorithm which we are designing for the decentralized immutable ledger, right? So this is so when it comes to adding blocks, you need some kind of proof to showcase that. So this is an algorithm which will make sense in when we go to the next tabs when we talk about the blockchain. So I'll just explain it that. But right now you can just understand that what we are trying to do is just find a hash which is a particular which has a particular properties. For right now, the property is that the first 4 digits should be 0. And for that,
Hello.
we just, yeah,
Sir, how did you find the nonce that you entered just now? Like you got the first four digits as zero. How did you find the nonce?
we just do hit and trial.
But that's a huge number. So
Yeah, it takes computation. That's why this when I click mine. So if I remove this, if I click mine, so what it does behind the scenes is just keeps on entering number one by one, and will give you the it will stop on the number when uh it gets the first 4 zeros. That's a huge number,
okay,
I
thank you.
agree. So like this is a very like computation heavy thing to do basically. We need a lot of good computation. Yeah,
So
and
just how
Okay.
proof of work is designed.
hmm?
Just how proof of work is designed. Like, do you need a lot of computation to find the
we don't
nonce?
we don't know what proof of work is yet, Krishna. Okay, so yeah, let's talk about this. Let's like this was one block. Now let's talk about a blockchain. Uh, cool. So right now, what we went from the last tab, we understood that we need some kind of uh, we need hashes which have the first few digits as zeros, and then if we keep on adding new blocks, like we just connect the blocks, block number 1 we connect it to block number 2, and we connect it to block number 3, then we get a blockchain. So so block number 1, when it has no data and it has the nonce of something, so now we have added one more field, which is the previous field. So what does this previous mean? Previous means the hash of the previous block. So for block number 1, it is the genesis block, and it will have the hash of all zeros. Okay. Then when we enter all these block nonce data and the previous into a hash function, we get some hash, and this hash will be the previous for the next block. And similarly, a chain is formed. Cool. And if I change anything in here, if I change the data, this hash will change because like I entered the data and it is putting it in the hash function. So the first 4 characters are gone as zeros. And if this hash is changed, this hash will change. The block number 3 hash will change. The block number 4 will also change. And the entire chain will basically be removed. So this is how we find if you are actually making changes to the database. So if we are keeping if we are keeping a blockchain which is public to everyone, so yeah, like this is how it will work. that if anyone is trying to make a change, we'll understand this because we are keeping the hashes saved. Right? So if we just put in any kind of data, we can find out where exactly the change was made because we figured out, okay, someone messed up the data in the number 2 block, and that's why all these blocks went red. So we are basically able to find changes. Why do we need this? Because we do not have a centralized power to make sure everything is going correctly. We want a decentralized power to do this. Yeah. Any doubts? Anything? This kind of takes time. It's fine. So yeah, like I'm expecting a lot of doubts in these particular slides, to be honest.
Yeah, I have a small question.
Sure.
Like each and every block has different values of hash, right?
Yes.
So, like each and every block behaves differently from each other. So each and every block has the same function, or they have different functions when they have different hashes.
So what we are essentially using the blocks are to store data, right? What the blocks are doing, we are just storing data in these blocks. Like there is some kind of data which is in block number 1, and when we calculate the hash of block number 1, we get some hash. Okay, and then what we do is use this hash as the previous value of this. Like this is the exact same one, 0001578. This is the same one. So now this hash becomes the previous value for the second block, and then we have some kind of data in the second block as well. We are trying to achieve a database in which if you make a difference, if you are a villain or if you are a virus or something, if you change the data, then all of us can understand where the data got corrupted and we can figure out things. That's what we are essentially trying to do. The data will just make sense. So yeah, every block is just storing data, to be honest.
Okay, thank you.
That answers. Anyone else?
Can you please explain why that previous box is used?
Yeah. So do you know how linked list works? Have you ever do you know the data structure of linked list?
Sorry, I don't know about it.
Sure, cool, that's fine. So what happens in a linked list is there is a so we need some kind of connection to say that this is the second block. We need that, right? So in the first block, uh, we have some data, and now we want to link it to the second block. So what we do is we take the hash and then use this hash as the previous thing. So this kind of acts a link between the first and the second block. Okay, so if you have the second block, you can find, okay, which block was um, earlier than this. We can find, okay, the block with this particular hash was earlier than this. So you can find out this way. So it kind of acts like a link. In a linked list, it is similar. What you have is a store, a value, a data, and then a pointer towards the next thing. So that's how a linked list works as well.
So does a successive block create a hash which corresponds to the previous hash which we have already generated?
Yes.
Okay,
Yeah.
okay. Thank
So you see, so like here the hash of block number 1 is used in the previous of block number 2. The hash of block number 2 is used in the previous of block number 3, and so on and so forth. Yeah. Okay. So let's understand distributed of version. So now, okay, now this was just one blockchain
Excuse
in
me.
the, yeah,
Yeah, I had one small doubt. Like,
sure.
actually, like, my doubt was that if I want to access the data of block number 3, okay, so can I directly access that, or should I navigate from 1 to 3?
You can directly access that. That's fine. It's just that we need to have chains of which block came earlier. That's why we are using that. You can directly access it. Will access right now. We'll check the blocks which get added in the Bitcoin layer right now. Okay.
Sure.
Okay. So now, so what we'll do is like, so we wanted to create a decentralized ledger, right? Decentralized one. So what we'll do is ledger is just a book which keeps the transactions. So every one of us will keep a book and everyone will keep on adding transactions. So this is peer A, the first person who has a blockchain of 5 blocks. Okay. And then we have peer B who has a blockchain of similar 5 blocks, same 5 blocks. Like it's just a copy basically. Okay. And and then we also have a peer C which has the same blocks. So everyone is keeping a copy of their own chain. Why? Because we do not trust anyone. We want to remove the trust factor, and yeah, basically that's what we want to do. So consider you are peer B and you want to change the data for some reason because you are a malicious person. So you just want to change this to hey. So we'll be able to figure out that the peer A and peer C would be able to figure out, okay, these hashes do not match, and that's why they will remove you from the network. So you will act as a bad actor, and the entire network will understand, okay, we can actually figure out where the problem is arising because we are using such kind of hashing system. Because if we change the data, um, we we could figure out, okay, this hashes got changed, and because these hashes got changed, we can understand, okay, this is the problem, this is the root cause of the problem. So what does this allow us to do? This allows us to have a secured, decentralized, immutable ledger. Because no one, not a single person is telling that peer B is wrong. Multiple people will say, and it's decentralized because of the same reason. It is immutable because if you try to change the data, we'll catch you, and yeah, it's a ledger, so we'll keep the transactions basically. Okay, any doubts, folks?
No doubts.
Hey, nice.
Yeah, I
These
have
are
a
some.
question, Harsh.
Yeah, sure, go ahead.
So can the number of the number of blocks in two different peers, can it be different?
Yes. So it can be different. So basically, what happens is whenever we keep on getting new data to store in the blockchain, the we have one central blockchain, and everyone just tries to copy that, and that's how things work.
Okay.
Yeah.
Your,
Yeah.
I just have a doubt.
Sure.
So say peer A is block 5, right?
Hmm.
I put that in, could I input it as peer B's block 1?
No, it's the same. It's the copy of the same blockchain.
Okay. So, and I can't split a blockchain, right? So block 2 can't go to block 3 and block 4.
I don't get it. Like, what do you mean by split?
Like, can the previous of 2 blocks be the same?
No, it will be always one after the other.
One after the other. Okay.
Yeah.
Thanks.
Okay. Any more doubts, people? Damn, you guys are much smarter than me. Like, it took a lot of time to understand this for me. Okay, so let's add transactions. So like we were talking about data. So now what we do is we want to replace the bank, right? So what does bank do? Bank stores the transaction. It never transfers the money. So these are some transactions right in front of you. And yeah, basically these are some transactions like, okay, this guy sent and I guess this is now readable. So Darcy sent $25 to someone, and Elizabeth sent $4 to Jane, and whatsoever. So now this is the data. What we did was in the last slide, what we had was simple data, but instead of data, now we have transactions. So we just put in transactions into the hash. Everything else is the same. Everything else is the same. We are still calculating the hash as the first four characters to be zeros, and we are using the hash of the first block to be the previous hash of the second block. And if we change any kind of data, if we change Parker to Peter, so the data will change, and the hashes will change, and we'll be able to figure out where the problem came from. Yeah. Cool. Anything? Any doubts? No doubts? Cool, folks. So yeah, that's how a blockchain works, to be honest. And what we do is like there is just one last addition that what we are trying to do is we do understand that the entire bank is just a big counter app, right? It's just keeping balance of each and every account. We do understand this that if you have 100 rupees in your bank account, you can just spend 100 rupees. You cannot overspend. And yeah, at the end, if we just figure out a way that everyone has some kind of balance in their account and they can only spend as much as they have in their account. So that's how. And if we are able to create such kind of system, that would be a decentralized network of keeping a currency alive. And that's what Bitcoin does. So this right in front of you, what we just discussed was the birth of Bitcoin. And what happens is whenever a block gets added, uh, we pay new coins get added, and these new coins are then later on circulated. So in here, Coinbase transaction gets added. So what a Coinbase transaction means is that whenever a block is added into the blockchain, the person who added the block will get rewarded, and then he can use those rewards to like spend. So when the first block got added, $100 were paid to Anders, and no one else has money right now because we at the starting of the blockchain, everyone's accounts will be zero, right? No one has money. So when the blockchain got started, the first person got the Coinbase reward, and then from the second block, he distributed this money to people. So Anders paid Sophia $10, Anders paid Lucas $20. So we now know that Lucas has $20 in his account. So now if Lucas tries to spend this money later on, he can only spend 20, not more than that. So in here we can see in the third transaction that $20 were paid in the third block. The $20 were paid from Lucas to Grace. So now Lucas has no money because he paid all the money he had. So yeah, every time a block gets added, new coins get minted, new coins get created, and those coins go to the person who added the block. So now he can use it wherever he wants, and this is how new currency gets added. This is how new money is printed, basically. So yeah, that's this currently right in front of you is how Bitcoin works. There are transactions in each and every block. Every block, when it gets added, someone gets paid, and whoever gets paid can use it. So yeah. Any doubts?
So this is basically you're buying a block and you are paying to someone else, right?
Not buying a block, I would say. Like at the end, what we want is like so ledger, as I said, I keep on mentioning ledger as a book because we keep on adding data to that book. And so with each and every block, new transactions will get added, right? You will pay to someone else, you are doing your things, someone in the world will be making transactions. So all these transactions need to be added into the blockchain. So some guy will add these blocks into the blockchain, and right now we'll check out what transactions got added into the Bitcoin. And yeah, so this is how things work. Like with each and every block, transactions get confirmed. If your transaction, if you are sending me one Bitcoin, if that transaction gets added into the blockchain, then it is confirmed, else it is not confirmed. Get it?
So how does mining work? Like
Exactly.
before
That's
people used to mine.
yeah, we'll come to that right now. That I'll explain it right now within like few minutes. Okay. So yeah. Any other question till then? No questions? Nothing? All cool?
Harsh?
Hello.
Yeah. Yeah.
Yeah.
Yeah.
Like
When
until
you
and unless
add
there is a transaction.
One at a time, please.
Okay, so whenever you add a block, who pays you?
Um, so So what happens is, so that's what mining means. Mining means to add a new block. I'll explain to you right now. Like as I said, the next topic for this particular presentation is explaining how mining works. And yeah, like I'll just explain it to you after this. Okay, just give me a couple of minutes to answer questions, and then we can go through mining. Okay.
Yeah, so until or unless a transaction is done, there is a block added. So what if there is no transaction done and there is no block continued, right? So is it done that way?
So if there are no transactions, the block will be empty. Yeah. So if there are no transactions happening, the blocks will be empty, and the blocks will get emptied and added. So, but when we consider a lot of cryptocurrencies, there are a lot of transactions happening all over the world. So that's how the blocks, we understand that blocks will always have some kind of data in them.
Okay, cool.
Hey, Harsh.
Yeah.
So exactly what do you mean? You remember like how Bitcoin's prices went up and down. So does that mean like a person gets paid more for creating a block and does it change or?
So when it comes to Bitcoin, we do not consider what it is current market value is. The current market value of Bitcoin is around like 16,000, 15,000 right now, $15,000. So that is an entire supply and demand thing, that if Bitcoin supply is less and the demand is more, the prices will go up, and similarly vice versa, right? So no, there is a particular, like we pay the person in Bitcoins. So like right now, every block every block which is added, it pays like around I'm not so sure if it's 6 Bitcoins per block. So if you get to add a block, you get
6.25.
6.25. Thank you.
6.25 bitcoins.
So it's a standard value basically.
I'll explain. We have some facts right now, like we'll add, I guess. Yeah. So yeah, that's how thing. It's not a standard value, it keeps on changing. Okay.
Yeah, every time the network goes an upgrade, it's the value changes. Like it's called Bitcoin halving.
Every 4 years. Okay, so yeah, let's talk about. So let's everyone understands these transactions, everyone understands this blockchain. So let's talk about Bitcoin after that. Yeah.
So I
Guys,
have
who
a
are
question. If Anders gets $100, right? So all the transaction with that $100 only happens in the blockchain for peer A, right? Like for example, Anders pays Lucas $20. So will Lucas have a separate copy of that $20? And it'll be a different copy of blockchain where he only talks about how those $20 are further distributed among his people, or is it all in blockchain A?
So the peer A, peer B, peer C all have the copies of the same blockchain. So it's just one blockchain.
And they're all members of the $100 that Anders originally distributed among people, right?
Exactly. So these exact transactions are added in each and every
So
block.
they all have all the transactions and they know where all that money went, not only their own money.
Yes. Okay. Anyone else? Sure. Let's talk about so guys, I present to you this website called mempool.space, where you can check each and every block which gets added into the Bitcoin network. All of it is public. Anyone can check it anytime, to be honest, which is not something that banks do. You cannot check, right? So this is private, and this is transparency. But let's talk about it. Okay, so there are a lot of things on this particular website. I'll break it down to you about what is happening, and a lot of things you already know because we just went through that example. So this entire purple blocks thing, this is the entire Bitcoin blockchain, starting from the 0th block to right now we are on some kind of block of 764 to 763. Okay, so this is the last block which got added. So in Bitcoin, every 10 minutes on an average of every 10 minutes, a block gets added. Okay, so now how does the block gets added? we solved the problem. We solved the mathematical problem which we had earlier to find a nonce which has the first four characters as 0, right? So what happens is, suppose, let's consider it from a transaction point of view. Suppose you are sending me some bitcoins. So now what you do is you just sign the transaction, you just send the transaction to the network. The entire network knows कि हाँ ये this transaction is happening. Okay, you are this transaction is just now done, but it's still not into the blockchain, so it's not confirmed yet. Okay, so it's not confirmed yet, and now we need to confirm it, right? If any transaction which gets added into the blockchain, then and only it is considered as confirmed. Okay, so now what we have is a memory pool. So this memory pool, I guess we can check it out here. Okay, this is the mining section. um, like they changed the UI UX of this particular website so much, and all of these are like created by my friends only, so never mind. So let's so what happens is, like, we have so bunch of transactions which are unconfirmed. So yeah, we can see here right now that there are 2000 transactions all over the world which are not confirmed yet. So whenever you make a transaction, that transaction is sent over to the entire network, like every peer, peer A, peer B, peer C, we have like thousands of peers. What they do is they have a gossip algorithm. So what a gossip algorithm is if peer A is connected to peer B, peer C, he'll pass on the information to them. This is how basically neighbors work in India. So if you tell something to your neighbor auntie, she'll tell it to those other aunties and stuff like that. So that's what a gossip is, right? So this is a gossip algorithm that if you have peers and so you'll just basically convey that, okay, this particular transaction happened. Okay. So right now there are 2300 unconfirmed transactions. So now the entire network knows these are the transactions, right? So now what happens is we need to find the person who will add the next block. Now whoever adds the next block gets rewarded, right? He gets rewarded, he gets some bitcoins. So now what is the challenge? Like, if you are getting a reward, what is the challenge, what is the catch, right? So what you need to do is, if you are trying to be the person who gets to add the next block, you are called a miner. So a miner basically adds blocks, so that's what a miner means. So what he needs to do is find the
So, excuse me.
yeah.
So every time
Yeah.
you add a block, you get rewarded.
Yes. The person who
Okay.
added the block gets rewarded.
And how much is that? Like, does that depend?
Yeah. So what happened is it is quite numerical. So when the Bitcoin network started, with each and every block, you get 50 Bitcoins for adding one block. So that's what happened when it got started. So this is around 2009. So around 2009, if you added a block of, you would get paid 50 bitcoins, and then every 4 years, the reward is halved. So for the first 4 years, it was 50, then it was 25, then it was 12, now it is 6, and so on and so forth. Yeah. So yeah, basically
Yeah.
50, 25, 12.5, and 6.25. Right now each and every block reward is 6.25 bitcoins. Why is this? Because we have an algorithm which is written in the code that there will be no more than 21 million bitcoins. There will be only 21 million bitcoins. After that, the mining will stop. Not mining will stop, but the rewards will stop. So after that, no more new bitcoins will be into the place. So there will only be 21 million. And right now there are 19 million bitcoins, uh, 19 million bitcoins into the circulation. So because like with each and every block, we get new bitcoins, right? The reward gets added to the miner. So now the miner will spend it somewhere. So basically new bitcoins come up into the circulation. So right now we have around 19 million, and considering the graph which we have, that every block with 4 years, almost around 4 years, the reward gets halved. We can calculate till that we'll get 21 million bitcoins by the year 2140. So till the year 2140, all the bitcoins will be mined. So that's like 100 years into the future. So it will take that much amount of time, because after 6.25, it will lower down to 3.125, and then it will lower down to 1. You guys get the math. Basically, I'm not that good with the division. So yeah, that's it. So what happens then? So how do you add a block?
Question.
Yeah, sure.
Yeah, so how do we know that if the how do we know that the transactions are confirmed? How does the confirmation takes place? Like if the transaction is confirmed or not?
Okay. So what happens is every transaction has a transaction ID. And if that transaction ID can be find, if you can find the transaction ID into the blockchain, that means it has been confirmed. Okay, so let's go through the block. We can check all the so like if this is the arrow, we can check all the transactions which were into this block. So there were 306 transactions. So let's go through this block. So three, and this is basically that the entire block could have this much amount of transactions, but only this much was filled. So yeah, so these were the amount of transactions which got confirmed. Like this transaction ID got confirmed. This transaction was of 1.6 bitcoins. Wow. So 1.6 bitcoins, that's around what? $22,000 got transferred from one place to the other. Yeah. So these are all the transactions you can go, which got confirmed in that particular block. You can, so if you make a transaction, you get the transaction ID, and in here you just need to search that transaction ID, and you'll find if the transaction is in the block. If it's in the block, it got confirmed. Okay, that answers your question. Hello.
Yes.
Yeah. Cool. So now, yeah. So now what we can talk about is how a block gets added. So every 2 weeks there is this difficulty thing. So what we need to do is, it's an algorithm, it's coded into it, that we need to maintain that we need to maintain an average. So see, the block got added. We need to maintain an average of like every 10 minutes a block should be added. Okay, so that's the rate we need to maintain. So what we do is every 2 weeks we change the difficulty. The difficulty of what? To find the nonce. So the nonce was this, basically what we had earlier in the block section, where we were finding a hash which had 4 zeros at the beginning. So consider if you have a very good computer with GPUs and a very cool hardware, very fast, very optimized. So you'll be able to find hash quickly, because this happens as a hit and trial method, right? So if you have a very fast computer, you can calculate hash quickly. So what I'll do is I'll say that we don't need 4 zeros, we need 6 zeros. So now the difficulty has been increased. Okay. So now the difficulty has been increased. It will take you much more time. Why did the difficulty increase? Because you had a very cool hardware. So everyone in the world fights to find the nonce of a block. So what the person does is tries to find the nonce. Everyone competes to find this nonce, to be the first guy to find this nonce. So this is what is called mining. So you just keep on hit and trial method. You just keep on adding numbers. Obviously, there are softwares to do that, and you try to find the correct hash depending upon the difficulty. And if you find the hash, you get to be the person who will add the new block.
Okay, so isn't the 4 digit like initial 4 zeros a fixed thing?
No,
But
it's
then
not a
how
fix.
can
It's not a fixed thing. It's not a fixed thing.
okay, you can change it.
The algorithm changes it depending upon the 2 week matrix. So consider when the Bitcoin network started, not a lot of people were mining, right? There were only few computers, so the difficulty was low, because you can even mine with your regular laptops. But then as soon as the network grew, a lot of hardware got integrated and a lot of new machines came in. Uh, People added GPU cards and whatsoever to increase their computation power. So that way the difficulty increased. So, and the difficulty keeps on increasing if the network grows. So with each and every addition to the network, the difficulty will increase. And that way the challenge, you need to fight with entire world basically to add a new block.
Okay, fine.
Yeah. So every 2 weeks the algorithm checks ki is the 10-minute per block rate maintained. If it is high, the difficulty, if suppose the blocks are getting added at 5 minutes per at every 5 minutes, we will increase the difficulty. If it is happening in every 15 minutes, we'll decrease the difficulty. So every 2 weeks this happens. And yeah, basically everyone will keep on competing to add these blocks. So we want an average of that. So this is all coded. And what you need to do is like whenever you are sending a transaction, you also send a transaction fee, uh, which is something, it's a transaction fee which you give to the miner to add your block, to add your transaction early. So this is what the fees look like. So a low priority transaction is something that you want to be confirmed, which can take time as well. So when a miner finds the nonce, he has this entire pool of 1500 transactions, out of which he can take any of the transactions and he can add them into a block. Okay, there is he can add any of these transactions. So what he'll do is he'll check all the transactions and find the transactions with maximum uh, transaction fee, because he is a greedy person. The miner is a greedy person, he wants to make more profit. So all these transaction fees are basically it goes to the miner's pocket. And if you want your transaction to be confirmed early, you pay a higher transaction fee so that your transaction gets confirmed like and within quickly. So right now, if the network is having a lot of traffic, the transaction fees needs to be paid higher. But right now it is very cheap. So it's like if you want your transaction to be getting added, it's like 2 cents or 47 cents if it's a high priority transaction. Yeah. So we basically went through what mining is. We went through what transaction fees are. So one common question is that after 21 million Bitcoins will be mined, what will happen? Will the network stop? So no, the miners will still get paid. Just the reward will stop. The um, Instead of the reward, right now the miners get the reward as well as the transaction fees. So after the 21 million Bitcoins are mined, the rewards will stop. They will just survive on transaction fees. So yeah, that's how it will be.
Excuse me, can you just confirm how the transaction will be confirmed? I didn't get the part.
Okay, so you are sending a transaction, you are sending me some Bitcoins, and that transaction is sent over to the network. Okay, so that happens, and then your transaction will go into this unconfirmed transaction pool. So now some miner who calculated the nonce correctly gets to choose what transactions he will add into the next block. Like in this block, only 300 transactions got added, but in this block, 1500 transactions got added. So this is something, the one that the miner decides, and the miner decides which transactions he wants to confirm. So if you pay a higher transaction fees, the miner will confirm it early, else it will get confirmed a little delayed. So yeah, that's how. So once your transaction gets added into the block, it is considered as confirmed.
Okay.
Excuse me, I have a doubt.
Yeah, sure.
Earlier you said that difficulty of mining depends on the system, right?
Yes.
So let us say if you have two systems like system A and system B, then and system A has superior hardware than system B, then will it be different difficulty levels for both at same time? I'm asking.
No. So like when if consider you want to be a miner, okay, you want to be the one. So like you need to compete with the entire world for that.
Okay.
So you will have the you need to beat everyone else in the world to be the first person to calculate the nonce. So the difficulty will be the same for everyone. Whoever finds the nonce at first will get to add the block.
So at a given time, it will be same for everyone, difficulty level.
Yes.
Okay, that's it. Thank you.
And here there are a lot of graphs and charts that tell you at what rate the transactions are coming. So basically, it was a high time at 506 because 7,000 transactions came in. There are a lot of analytics you can run. Yeah. Any many more questions? Yeah, sure. Go ahead.
If we talk about the value of hash, so are people competing only for the zeros, or we can take any other digit like 1, 2?
Zeros only. Zeros only.
Only zeros. What's the
The
reason?
amount of it's the algorithm. The amount of zeros obviously change. That it can be of different number. Like when I showcased the demo, it just had 4 zeros, right? But it can be changed. It can be 10. It can be 0. It's not. There is not. It's like the code basically. It's basically that we need to find a hash having certain traits. So that's what I'll say. In a general form, a hash should have certain traits. If you are able to find that hash, uh, if you are able to find that nonce, basically, then you get to mine the block.
Okay, so the value of nonce we are finding manually or with using some software.
It's a hit and trial method. You can try manually, but computers are better than humans.
So manually we have to check from 0 to infinity.
You can do that uh, if you are what strong enough, strong-willed enough, obviously. So
True.
yeah, so yeah, obviously, like we use computers to do that. We use simple loops, and there are a lot of things. So I'll just showcase you how a Bitcoin farm looks like. So, um, all these GPUs, this is what a Bitcoin farm looks like. These are all machines. All of those machines are trying to just put hit and trial method and trying to find the nonce. Again,
nice.
So these are pretty big players. These are all the machines. Like there are coolant systems for these. There are special chips for these. There is something called ASIC. I'm not so sure the full form, but ASIC miner. Yeah. So yeah, this is an ASIC miner, which is application specific integrated circuit. Means like how you have Intel chips and Apple chips and whatsoever. Those are basically those processor chips are meant for computer devices. These ASICs are only meant for mining. Only meant for mining. They can't run any other program, so that they can be much more efficient. So this is an ASIC miner, and yeah, now consider this image. Like they have so many ASIC miners. So this is the computer. This is just one of the Bitcoin farms, and there is a lot of Bitcoin farms out there. So this is what a Bitcoin farm looks like. All of these machines are trying to find that nonce.
Okay.
Yeah. Any other questions?
Harsh?
Yeah.
You mentioned that the miner gets to pick and choose what transactions to confirm, right?
Yes.
So what exactly is it looking like? Does it look at any specific thing while it wants to confirm, or it's just a lottery system?
So every transaction has a transaction fee attached. Okay. If you are sending me a transaction, you also send transaction fees. So what the miner will do is it will look at all the unconfirmed transactions. Ideally, we consider that the miner is greedy, because greed is the only trait we can trust a human to have. We cannot trust a human to have sympathy. We cannot trust a human to have empathy. We can trust a human to have greedy, because that's how humans are made. So Yeah, so that's how it works. So like there are 1,000 transactions, and the first 200 transactions have a lot of transaction fees. So you are a greedy person, you are the miner. What you'll do is you'll take the first 200 transactions and you'll confirm them. So that's how it works. So like you can check what is the high priority transaction fee right now. So if you pay 7 cents, SAT was like if you pay that much, so your transaction is given a high priority. So your transaction will be confirmed earlier.
Okay.
Yeah.
Yeah. Got it. Yeah.
And in the blockchain world, we trust all of the actors to be greedy. So that's how we function. So that's the thing. Yeah. Yeah. Go ahead. Someone was asking a question.
Yeah, is there a limit to make blocks in a single peer?
In a single.
Peer.
So
Like
all the peers are keeping a copy of the blockchain, right?
yeah.
Right? Yeah, all the peers are keeping a copy of the blockchain. So this is the main blockchain which is right now shown in front of you, the screen. So whenever a block gets added, the peers will make a copy.
Okay.
So peers are the one who will basically peers are called nodes. So just nothing, the same thing what peer is, it's just called nodes. So the nodes are the one which keep a track of the blockchain history, and miners are the one which keep on adding blocks.
Okay. So
Right?
as you said, like two different peers can have number of blocks, like different number of blocks. Like peer A can have 5 blocks and peer B can have 6.
all
So
the
how
peers will have all the peers will have the copy of the same blockchain.
same block, like number of blocks will be same.
Yeah.
Like peer A is the head. You're
No,
trying.
no, 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 no peer is called the head. There is this one blockchain. So what happens is when a block gets added, so a block, if all the peers, so like if all the peers agree that this block has been added into the blockchain, everyone will add that particular block into their copy. Everyone is keeping a copy of their of the entire blockchain because we do not trust anyone. So yeah, so basically consider a block gets added. So what the peers will do is, okay, they'll tell everyone, okay, the block has been added, the block has been added, the block has been added. It's a gossip algorithm. And yeah, then that's how the entire network knows a block has been added. And if everyone agrees that the block has been added, the block has been added.
I
Okay.
have a question.
Sure.
Yeah, is there any limit to how many peers can exist at a time?
No. The more the merrier.
Okay, cool.
There is no limits. To be honest, like at the starting of the network, there were a lot less peers, and right now, I don't know how many Bitcoin nodes are there. Bitcoin nodes number. There are currently over 10,000 full nodes. Full nodes means someone who keeps the entire copy of the chain. So I didn't know that number, but okay. Anyone else? So basically, like this was a lot to get in, and I'm not so sure how much time do we have left. But yeah, we can also check. We can also go through the how a transaction is signed and whatsoever. If we have the time, and if you guys are interested, we can go through that. Else, this was a
I
lot to
forgot
take
what,
in.
sorry,
Yeah.
I forgot what nodes were.
So nodes are basically someone who keeps the copy of the entire blockchain history. The peers, basically. The in the demo I showcased peers. Those are called as nodes, basically. Those are called as
Okay, fine.
nodes. Yeah. So peer A, peer B. You can play around with this particular website. I'll just link it, and if the chat is not working, I'll just send it over in the Discord or whatsoever. I'll send
Yeah,
it over.
Harsh, you can send it to me. You can send it to me. I'll just put it out, ping it out to them.
Sure.
Ideally,
I'll
the
do that
chat
after.
option will work from the next session. That is the key goal, and the Q&A also.
Thanks.
I have a question again.
Sure.
Yeah, so how do peers get created? Like, is there an algorithm or something that creates the peers, or it gets added manually or something like that?
No, it's just the well. So if you want to be a blockchain, if you want to be a Bitcoin peer or Bitcoin node, what you'll need to do is just get the software of Bitcoin Core and download the entire history what we have currently, and then you will be at the peer. There is this software which you need to run, Bitcoin Core, um, which is you can download it here and whatsoever. So for any operating system you like, and once you download it, you can download the entire history of the Bitcoin blockchain. So the entire history starting from the 0th block. So then you will be considered as a full node. Not something which I would recommend to do on your local computer, because I have lost a computer trying to do this experiment. I basically burnt off because the entire blockchain was too much for my computer to handle. So yeah, uh, not something which needs to be done at home. So yeah, that's all. But yeah, anyone can be a peer. They just need to run the software Bitcoin Core and they need to have the entire history. So anyone else? Huh? Yeah.
So anyone can have access to your transactions in Bitcoin, right? Even though they're encrypted in the hash form. Anyone can
So
look at those encrypted transactions.
you can so basically how it works is like an email address. So if I have your email address, I can send you emails, but I can't send emails on your behalf, right? So my email address is something something, and you, if you know my email address, you'll be able to send me emails, but you cannot send email through my behalf. You cannot be Harsh and you can send email through mine. So right now this particular address, let's go through this address. So this address, we know this address, but we don't know who this address belongs to. We know that this particular address has received 6.63 bitcoins, and we know the balance of it, but we do not know who this person is, and we cannot use this 0.63 bitcoins. Only the person who holds this particular address can use it. So that is something which is done with keys, public and private keys. Will that is a later topic, but yeah, we can talk about that.
Right, thanks.
So, and basically you can stalk any address. You can, if you know an address, you can stalk how many transactions they did, uh, but you cannot find out who the address belongs to. Like that's how transparency as well as privacy is maintained, because this is a address and you cannot find out the name of it. That is transparent. You can still check out this particular address owns 1.7 bitcoins. Pretty jealous of this one, but again, a lot of money in here. So yeah. Anyone, any doubts? Because like this was a too much. If you understand this, so it will be much easier to create applications on blockchain, because now you understand why we needed decentralization in the first place. And yeah, it just took us almost an hour to understand all of these. Cool. You good to go? Yeah.
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 Yes. Let's go. Do we have time left, Krishna?
Yes, Harsh. You have quite a lot of time left. I think you can do it for another 10 to 15 minutes, or else if it's enough to soak in for everyone for today, we
Huh.
can just hold it at here.
Yeah. So the next part was like just like how do you sign a transaction? If you guys want, we can talk about it. Else, if yeah, if this is if you are already exhausted or something, we can stop as well. So that's fine.
I think, Harsh, ideally we would let the people soak in the information what we have done today, and yeah, I have been receiving a lot of messages that yeah, we'll soak in what we have done today, and we will go ahead.
Cool. Let it.
So,
Let's fine. So yeah, if there are any
Harsh,
questions, yeah, sure. Yeah.
not a doubt exactly, but can you just have a brief talk on your journey in this particular field, like how you started off and how long did it take for you to get a good grip on this, but good understanding of the different kind of how people work in this particular field and stuff like that.
Yeah, sure.
And it would
So
be better if
Definitely
you
the
could
question
just
you have to.
give a.
Yeah, excuse me. This is the definitely question you have to ask Harsh. We have to design a specific session for this because we will make you understand exactly what it is required to become a blockchain dev. So ideally, we would have a specific session for this, but please, Harsh, go on and answer them regarding this. It is actually not so tough, and there are not a lot of barriers than what you think. Uh, Harsh, please go answer. Go answer it.
sure. Fine. So basically, I was into like I just graduated this year. I am a 2022 graduate. I used to do open source a lot. I used to do a lot of things like web dev, app development, and a lot of things in my third year ending. But like all of those domains were not something which were very much exciting to me. So what I did was I started putting my pocket money into the cryptocurrencies because it was just like COVID just started. We just had a lot of like if you want to play around with your pocket money, so you can do that. And so that's when I understood that open source, like I already loved open source. I used to participate in a lot of communities and a lot of events like Gold Script Summer of Code and things like that. So yeah, and then I got to know about cryptocurrencies, that cryptocurrencies basically are decentralization plus like you can code as well, it is open source as well, you can make money as well. So I was like very much interested into that. So I found out about this particular event, not an event, but some kind of a open source program called Summer of Bitcoin, which is kind of like Google Summer of Code, but it is Bitcoin related. That there are a lot of projects which will be happening in the Bitcoin uh, ecosystem, like all the code bases. I'll just showcase the GitHub. For some reason, whenever you search Bitcoin, it always ends up trading. So yeah, the entire software of Bitcoin is open source. It is available on GitHub. Even you can make contribution towards it. So this is the repo Bitcoin/Bitcoin, and there are like 400 issues, 300 pull requests, and a lot of things. So you can contribute to the this entire big revolution we are part of. So Summer of Bitcoin was an event which basically helped me to understand all the things regarding basics of blockchain, like all the things which I just taught. So I spent an entire summer to do this, and I was also contributing to this particular repository, to this particular code base. And yeah, that's how I understood blockchain. It took me time to understand the cryptography. I was much more interested in that, like how is this happening so much securely at a mathematical level. So that was something which is a tricky part. It's not necessary to understand this. If you're a mathematical enthusiast, that will help you a lot. So I had that kind of kick, so I did that. And yeah, after learning this, after spending an entire summer with Bitcoin, I went through doing other chains, which are like there are some more chains. There are a lot of other different kind of blockchains. The entire system which we just discussed, like how miners fight to find a particular nonce, then the miner who wins gets to add a block. This entire algorithm is called proof of work. That you need to showcase that you have done work by showcasing the nonce. If you showcase the nonce, it is a proof of work that you have fought with the entire world. You have spent the electricity which goes in running all these computation, and the mathematical power which goes into the computation, right? So after spending so much amount of time into that, you basically showcase this. So this is called proof of work. So Bitcoin works on proof of work, and there are other blockchains which work on a different algorithm. So Ethereum is another blockchain which is quite popular. So it allows you to code as well on top of it, and that is something which we have later in the course, like after a few days, I guess. So yeah, I basically started taking participation in different hackathons which were blockchain centric, and I started getting projects into top of it. Then I had the opportunity to work at Solana Labs. Solana is another blockchain. I have scored a fellowship there, so I was able to work with Solana core engineers and was able to contribute to the Solana repository there. So yeah, that's and it has been quite a big journey, to be honest. Like it's been 2 years almost, and right now, and it has been fun. I won't say that everyone should be into the blockchain. I particularly found it fun because every day something new happens in here, and it kind of gives me the reason to consume content daily. Like I enjoy reading blogs daily. I enjoy going through articles and research papers. So yeah, if you are looking for a industry which challenges you every day, this might be for you. Not everyone might be having an interest to learn blockchain. Some people are having different interests, and that is totally fine. That is totally okay. But yeah, if you are someone who likes to challenge yourself daily, I guess this domain is pretty cool. I have been like, there is not a single day passed where I've been bored of learning something, like bored because of this. So yeah, that's the reason which kept me going.
Okay, and our friend, are you from RVC by any chance?
Are you from?
Like RVC, our college.
No.
No, he is not. He's a pass out.
I'm from Vadodara. I'm
And
from Vadodara.
he just passed out this year, so yeah.
Yeah, I just graduated like a
Yeah.
couple months ago, few months ago.
But still, he's doing a DevRel job at a topmost companies in blockchain. So that's the pretty cool perk you have when you finish the program.
That's fine. It's like I have had good opportunities, to be honest, knocking at my door, and yeah, I was having cool. So it was pretty good, to be honest. So yeah, that's my story. If
Thanks
there
a
are,
lot, Harsh.
yeah,
Thank you for helping us out with this first session of the day one of the cohort. It was amazing to have you today. Looking forward to have you for a couple of more sessions on week one, and ideally impart your knowledge to everyone what you have. This was very not impactful for people, you learners, to get to know a lot of things. Thanks a lot. See you again in tomorrow's session.
sure. So yeah,
Going
fine.
ahead, we would request everyone to create a Twitter account just now so that they can tweet about the event, tagging @Harsh. We'll be
It's
sharing
fine.
across the links in the WhatsApp group. You are requested to share across the tweet.
It's fine. It's just like whatever you guys learned today. I would just ask you guys to like just write it somewhere. It should not be. It is okay if it's on Twitter or if it's just in your personal diary. It's that whatever you learned, just keep a track, because like this entire cohort is of a few weeks, right? You learn a lot of things daily, so just keep some kind of code, some kind of like data that you learned this, so that if you look back into it, it will be like a revision for you. And like if you enjoy it, kind of cool as well. You can write a blog as well. That I used to write blogs about whatever I learned. So even right now, whatever content I create, I refer the content back because I do forget things. So yeah.
Thanks a lot. Going ahead, Akshat will be joining you for the session to showcase you about the website and the learning management platform that is going to help you during the due process of the cohort. All the recordings, all the details about the cohort is going to be uploaded on the official website called bobdow.in. Thanks a lot. Akshat, over to you.
Thank you, Krishna. I'll be now sharing the website and how you'll be able to access all the video recordings and some of the assignments and quizzes that our educators will be providing. I'll share my screen first of all. Okay. So is my screen visible? Can I see some show of hands, raising hands, so everyone can confirm that my screen is visible? Okay. Thanks everyone. Let me just go to the next window and show you how to access our website. So the name of our website, which you will be getting all the content, is bobdow.in. So I would like everyone to open a tab next to their Meet and follow through the process, because we are going to be registering ourselves as a student here. You can explore the website a bit. This is our website called bobdow.in. So the first thing you guys have to do is go to this cohort section of the bobdow.in. Any doubts, please, anyone, please like intervene and ask.
Hello.
My internet connection just went out.
Thought we lost you.
Follow?
Yeah.
Yeah, my internet. So I'm back, right? Yeah, great. I'll share my screen once again so that everyone can see. Okay, great. Okay, so everyone can see me, right? Please show of hands. Okay.
Yeah.
Yeah, bro, I can see you.
Yeah. So everyone has come to the Bob.in website. Go to the cohort section of this website. If everyone has come to this page, please give some verbal confirmation. Anyone unmute the mic and just tell, yeah, you've got here.
Yeah, I have gotten to this page, man.
Okay, so start registering. Type your name. Type your username. Type your email. And type a password which you want. After doing all of this, typing your name for last name, username, email, and I would like everyone to type their RVC email address here so that it will be easy for us to track attendance. Has everyone finished this process? Please, can I get a verbal confirmation?
It would be easier to access quizzes and do every setup ideally.
Okay, ideally. So this will be like a proper professional way to interact with all our fellow interns through this platform. So can I get verbal confirmation that everyone has got through this process?
Can you just repeat it again? I just lost track.
Okay, so first everyone go to bobdow.in.
Because I'm not to know properly. I have gone to the
Okay,
Bob.
so I'll go slowly a bit.
Yes, thank you. I got it.
Yes, 1 second. I'll repeat the process once again. I will repeat the process.